This is day 34 of 50 days of tutelage. In today's class, we'll be talking about coordinate geometry. So what is coordinate itself before we talk about the geometry? Coordinate is just simply a way we describe a point or a place. A kind of description that from a reference point, if you follow that description, you're going to be able to arrive at that point. So if, for instance, we're given a point here, and then you have someone standing right across the point here. So someone could say that, oh, there's a point located just 4 steps ahead of me or 4 steps in front of me. So you have 1, 2, 3, and you have 4. Don't mind me, I'm just like approximating. And if someone is maybe standing around this place, they could say that there's a point that is 6 steps just to my right. So you can have 1, 2, 3, 4, 5, 6. So 6 steps just to your right. Now, what you have been able to describe here is actually a form of coordinate. Now, in that coordinate, you have used the one-dimensional coordinate to describe this. However, what we notice is that when we have lower dimensional coordinates, they are not able to properly describe a point, especially if everybody is not in that same reference point. So, but at the same time, every coordinate still has to be defined from a reference point. That is why there's always a point of origin. So in this case now, the origin is from this person, the origin is from this person. But it becomes a little bit difficult if, let's say, you have somebody around here now. So unfortunately, somebody around here, you will not be able to properly describe the coordinate of this point, even if you want to use them as the reference point. Because as it is now, this is their front, this is their right, and this is their left, and this is their behind. But when you notice this particular point now, this particular point is nowhere in that line of view. Instead, it is sharing a point from their forward and their right. So it is in that particular place now. So when we are faced with problems like this, the one-dimensional coordinate will not be sufficient. So therefore, we need a two-dimensional coordinate. In a two-dimensional coordinate, we like to use the horizontal versus the vertical, or we use x and y to represent. So x will stand for the horizontal, and y is going to stand for the vertical. Of course, there is three-dimensional too, but I'm not going to be doing more of three-dimension today. That is x, y, z. In this case, we are considering depth and height. You know, this one is just for a plane. X and y is just for a plane surface. But when you begin to consider z, a third dimension, then you're considering depth and height. So meaning that from the plane, you can go up, you can go down as well. But I'm not doing 3D today. I'm going to be focusing more on 2D and then 1D as well. So in this case now, if you want to describe this now, you can ask the person to move, let's say, 4 steps to the right, then they move what? They move like 4 steps upward as well. So with that now, you have used a 2D to represent the description of this point. And this is what coordinate is all about. Now, when you begin to, the geometry now comes in when you begin to consider the relationship between several points like this. Like this position, the reference point is a point as well. So you begin to study the line that join them together. You begin to study the relationship between points and all of that. Then you're talking about geometry. And that's basically the introduction to coordinate geometry. So let's start with, so let us say we have like this. This is a vertical axis and this is horizontal axis. So automatically that makes this place the origin 0, and that implies that we have 0, 0. 0 for the x-axis and 0 for the y-axis as well. So when you go to the left, you have a negative x-axis. When you go to the right, you have a positive x-axis. When you go up, you have a positive y-axis. When you go down, you have a negative y-axis. So now you can describe 2 points in this place. So let those 2 points be points. I'm going to make this a little bit bigger. I think I should just redraw them. I'm just going to redraw it. Okay, I think I should use black. So let me draw this here. We have this, and we have this. Yeah. So this is the x-axis. This is x, and this is y. So this place, we have the origin, we have 0, comma 0. Now, how do we exactly express things here? So I can describe 2 points here. So let there be 2 points. Let this be point 1 and let this be a point 2. So let's call this one point 1 and let's call this one point 2. So in this situation now, this point can be described using x1, comma y1, and this point can also be described using x2, comma y2, which definitely implies that if you trace this point down to the x-axis, if you trace this point down to the x-axis, I'll just use a broken line to do the tracing. So if you trace this point down to the x-axis, and then if you trace it to the y-axis, it will correspond to a particular y value. If you also trace this point down to the x-axis, it will correspond to a particular x value. And if you trace this down to the y-axis, it will correspond to a particular y value. So in that situation, this place is going to be x1, this place is going to be x2, this place is going to be y1, and this place is going to be y2. So I've explained this whole description earlier. Now, when we now begin to consider the interaction between these 2 points, then that is where the geometry comes in. So this x1, y1, x2, y2, they are the coordinates of this point. So these are the coordinates. So coordinate is always represented in this manner, and this is the two-dimensional representation. So now, if I draw a line, a straight line joining these 2 points together. So let's draw a straight line joining these 2 points together. So we have this straight line joining these 2 points together. Now, the analysis that we can do with this point is that we can do so many things here. For instance, you look at this line, it's forming something like a triangle. It's forming something like a triangle. So with this now, I can extract a triangle out here. Yeah, a right angle triangle. And with this right angle triangle, you can get the distance from this point to this point. You know, if you're going from, let's say, 2, you go to 3, you go to 4, you go to 5, and you want to know how much distance you have covered in total. You could say 2 to 3 is 1, 3 to 4 is 1, 4 to 5 is another 1. So 1 plus 1 plus 1, that is 3. But you can also just do 5 minus 2, the final minus initial, and you get the distance covered. So if you have moved from x1 to x2, that means that the total distance at the bottom here is going to be x2 minus x1. And then for the one above here for y as well, this is going to be y2 minus y1. So let's call this place D. D, which is the distance between this point and this point. So if you want to find the distance between any 2 points whose coordinates are given, this is a right angle triangle, and so therefore you can use the Pythagoras theorem. So knowing that D is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So with this now, you know that when the coordinates of any 2 points are given, you can easily find their distance, the distance between the two of them, using this expression. So you can see we extract that from the right angle triangle that they form. But that's not the only thing we can get here. We can also get the slope of this line, the slope of this line. Slope is always given by, so slope is represented using the letter M. So this is slope. So slope is going to be a change in y divided by change in x. And change in y is always y2 minus y1 divided by x2 minus x1. By the way, you can actually pick any other 2 random points on this line. You can pick this point, you can pick this point. Since it is a straight line, it will always give the same slope. So the only thing you have to be conscious of is that whenever you're picking x1, that same point is where you pick y1. Whenever you're picking x2, that same point is where you pick your y2. So you don't have to mix them up together. So take note of that. And then you can make this one your x1, y1, and make this one x2, y2. Like I said, what really matters is that if x2 is here, y2 is here. If x1 is here, y1 is here as well. So once you make sure that is okay, then you're good to go. So in this situation, we have this slope. But like I said, you can actually pick any random point here. So let's say I'm fixing my x1, y1, that is the point 1. And now I want to pick an arbitrary point here. I don't know the value. In this place, I know the value of x2, I know the value of y2, I know the value of x1, I know the value of y1. That's why we label them like that. But let's say I pick an arbitrary point here, and I call that point x comma y, meaning I do not know their actual value. I just arbitrarily pick them. Then I can actually, do the two of them together such that my 2 points will now be x1, y1, and x comma y. So this way as well, you can also find the slope. That will be y minus y1 divided by x minus x1. And this is also going to hold for any arbitrary point that you pick. So like I said, you can pick any point and it will always work. And this expression is going to be very, very useful whenever you want to find equation of a given line. So I've given two things now. Number one, the distance between 2 points. Number two is how to find the slope of lines at the end, two points. Sorry, the line joining 2 points. Now, let's talk about midpoint of this line. So what is a midpoint? Midpoint is definitely, if you are to move on this line, what will be the halfway point? What is going to be the halfway point? So to get the halfway point, we actually kind of use the reference of this x1, x2, and also y1, y2 as well. So what's the halfway between x1 and x2? That's simply the sum of x1 and x2 divided by 2. So the halfway is going to have a coordinate of x1 plus x2 divided by 2. And the halfway here, we have a coordinate of y1 plus y2 divided by 2. So therefore, the midpoint of those lines, will then be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Now, these are the major things that you will need to know how to find within this line. There are other things as well, but for now, I'm going to be discussing these three major things. So which actually leads me to the study of the line itself. The line is a straight line, and then we can actually represent it with a certain linear equation. I've taught you about linear equation before, and this will actually give you much better perspective about linear equations. For every linear equation, we can always represent them with a straight line. And in terms of these, every linear equation is represented by this general formula: y equals mx plus b. Or every line, straight line, can be represented using a linear equation: y equals mx plus b. So in this case, y and x, both of them are the variables. M is the slope, of course, it is a constant, and b is known as the intercept. The intercept on the y-axis. So basically, we're saying that y is where this line will touch the y-axis. So if you extend this line further now, whenever it touches the y-axis, that is going to be what your b. That is going to be what your b is going to be. I didn't mean to use that anyways. So now, how can we determine the equation of a line? Or if you're given the equation of a line, how can you actually determine some things out of it? So we've seen that the major things here are the slope and the intercept. So very, very, very important. Now back to this slope representation I did earlier. Back to this actually. The purpose of this particular thing here is to be able to help us find the equation of a straight line. And I'm going to explain to you how that is so very soon. So you find the equation of a line given some conditions. These are the necessary and sufficient conditions. Now, either of these two will always hold before you can find the equation of a line. If you are given the coordinate, so let me just use this, coordinate of any 2 points. Coordinate of any 2 points on the line. So if you have the coordinate of any 2 points on the line, then this is necessary and sufficient to find the equation of that line. So you want to find the equation of a line, just get the coordinate of any 2 points on the line. The second one is if you have, number one, you have slope and coordinate of any point on the line. Now, this is different from number figure 1. If you have the slope of the line, that's number 1, and you have coordinate of any point on that line, then you will be able to find the equation of the line as well. This is also necessary and sufficient. Now, the two of them does not necessarily have to be. Only one of them has to be true. But you can see that each of them involve two things. This one involves coordinate of any 2 points. The second one involves having the slope and the coordinate of any other point in that place. So let me show you how that is going to be done. So back to this equation now. If you have the coordinate of any 2 points, automatically you can produce the slope. And the moment you produce the slope, then you can easily find the equation by using an arbitrary y and x. Let me quickly show you an example here. So if you have, let's say, if I give you 2, 4, and I give you 3, -1, and I want you to find the equation of this line, I'm going to show you something now. So let's say this one is x1 and this is y1. If this is x2 and this is y2, how can we then find the equation of this line? So what we do is that we want to find the slope first. If you find the slope, you can say the slope m equals y2 minus y1 divided by x2 minus x1. And this is going to be -1 minus 4 divided by 3 minus 2. You can see how I'm tailoring everything properly. You need to be very, very careful when you are doing your work. And so this is going to be -1 minus 4, that's -5. -5, 3 minus 2 is 1. So that means that the slope is -5. I'm going to still tell you more about the property of the slope very soon. So, but let's deal with the equations first. Now that I have the slope, I can go back to this now. So I've used this to find the slope. Now I'm going to say the slope m is actually equal to this. So let's do that. So we have slope -5 equals y arbitrary minus, what is x1 again? X1 is 2. Oh, sorry. Y minus y1. What is y1? Y1 is 4. Then divided by x minus x1, which is what? Which is 2. So I'm only using, so I think I should copy this out so that you can follow what I'm doing. So I'm only using the arbitrary part here. So I'm just going to paste that right here. Yeah. So let that be right here. Now, so y minus y1 divided by x minus x1. So when you do all of these and you try to make y the subject here, so solve for y here. So in this place, you have, this implies that y minus 4 equals -5 multiplied by x minus 2. And so you have y minus 4 equals -5x plus 10. And so you have y equals -5x plus, this will be -4, it's become +4. So plus 10 plus 4, that is going to be 14. And this is going to be the equation of that line. So the equation of the line whose that has these 2 points, that contains these 2 points, 2, 4 and 3, -1, is y equals -5x plus 14. And you can read here that -5 is going to be the slope. So -5 is going to be the slope, which we already know. And 14 is going to be the y-intercept. So somebody would ask, you had chosen x1, y1, 2 and 4. What if you chose 3 and -1? Would it still give the same thing? So if I choose, actually, if I choose these 3 and -1, that is x to be 3 and then y to be 1. So let's see how that will go. That will be -5 equals y minus, so y minus -1 divided by x minus 3. So this is going to be -5 equals y plus 1 divided by x minus 3. So that would imply that y plus 1 equals -5 multiplied by x minus 3. And this would imply that y equals -5x plus -5 times -3, that's 15. And plus 1 will be -1 here. So that implies that y is -5x plus 14. So you can see we still get the same result. So as long as you do the correct thing and you're consistent with how you're picking your values, you will always get the same result. And that is how you can get the equation of a line. So you can see I've explained these two using that. So when you have the coordinate of any 2 points, you can use those 2 coordinates to get the slope first. So, but in case you have been given the slope already, you just proceed to do the final thing. Equate the slope, pick an arbitrary point, and pick one of those points that you are given there. And then that's it. You'll be fine. So, The last thing I want to talk about in this video, of course, in the next video, which is coordinate geometry 2, I will talk about relationship between two lines, the angles that lie between them. So for instance, if you have perpendicular lines, if you have lines that are at an angle to each other, or you have parallel lines and all of those things, and how can you find equation of a line from that point. I also talk about the equation of a circle. So that is for the next video, which is why you actually need to subscribe to my channel, and ensure you like this video as well. So lastly, let's describe what different slopes, what do they mean? So you can have a slope that is positive, that is greater than 0. You can have a slope that is negative, that is less than 0. You can have a slope that is equal to 0. And you can actually have a slope that is undefined. So let me just say undefined. A slope that is undefined. What do these things mean generally? This generally means that there is an increment. That is, as x value is increasing, y value is increasing as well. So you have something of this nature. This one means that as one of the values is increasing, the other is decreasing. So a negative slope represents a decreasing graph. So you see something that looks like this. So it is always falling as it's going from left to right. This one means a constant. That is, the y value is constant as the x value is changing, and you have something of this nature. This one means that the x value is constant even though the y value is changing, and you have something of this nature. So with this, you should be able to identify any form of line based on the slope that you are given. And that's basically what we are going to be covering in today's class on coordinate geometry. Don't forget to hit the subscribe button and drop a comment as well. I'll see you in the next one.